The topic of this video is solving rational expressions equations. Let's look at a problem. 21x minus 40 equals 21 over x. Believe it or not, the hardest part of this problem is recognizing that it fits in this category. Many students see this, they see only one fraction, and they don't really know what to do because it doesn't look like the other problems of this type. But anytime you see a fraction inside of an equation where there's a variable down in the denominator, you're dealing with a rational expressions equations, and we need to follow the same steps. Let's begin with step 1, determining what the answer cannot be. We only have one denominator, and that denominator is not allowed to be 0. So this is a very easy step. X is not allowed to be 0. Steps 2, 3, and 4 is where we find out what the answer might be. And the first step to do that is to make all of our terms fractions with the same denominator. So we're going to write the 21x as 21x over 1. We're going to write the 40 as 40 over 1. And we're going to leave 21 over x exactly as it is. Now make all the denominators the same. This first fraction needs an x, so multiply by x top and bottom. This second fraction needs an x, so multiply by x top and bottom. Now, even though it's not necessary, you may multiply by 1 top and bottom here, just to get a visual sense that all of these are exactly the same thing. So what do we have? 21x squared over x minus 40x over x equals 21 over x. So our least common denominator is x. So what we're going to do is we're going to replace the x in the denominator with LCD. Our next step is to multiply both sides by the LCD. So the whole left side and the whole right side will get multiplied by LCD. On the left, we use the distributive property, and on the right, we simply multiply. So when we distribute this LCD to the first fraction, these LCDs cancel because this one's up top and this one's down below, leaving us just our numerator, 21x squared. When this LCD is then also distributed to the second fraction, the same thing happens. LCD cancels with LCD, leaving me just my numerator, so I'll have subtract 40x. On the right, this LCD cancels with this, leaving me just the numerator, 21. All right, now we have to solve this equation. The first step is to get equal 0. So subtract 21 on both sides, and we get 21x squared minus 40x minus 21 equals 0. Now we have to solve this quadratic equation. There are several ways to accomplish this. You can factor, you can complete the square, or you can use the quadratic formula. In this particular instance, completing the square would not be the correct choice because we have a very messy number here, a 21. We'd have to divide both sides by 21, which would make our middle term coefficient a fraction, and that would be a very, very challenging way to proceed. So I recommend either factoring or the quadratic formula. We haven't done the quadratic formula in any of our other videos, so let's go ahead and do the quadratic formula now. A equals 21. B equals negative 40. C equals negative 21. The quadratic formula says x equals opposite b plus or minus the square root of b squared minus 4ac, all divided by 2a. Whenever you write the quadratic formula, always make sure you write the x equals, and make sure that your fraction bar goes from the equals to the end of the radical. Now we can plug in. If b is negative 40, then opposite b would be positive 40, plus or minus the square root of negative 40 in parentheses squared minus 4 times 21 times negative 21, all divided by 2 times 21. 40 plus or minus, a negative squared produces a positive, and 40 squared is 1,600. Counting the number of hyphens after the exponent of 2, we see that there are 2, which is an even number, so we add. And we need to know what is 4 times 21 times 21. 1764. All divided by 42. X equals 40 plus or minus the square root of 1764 plus 1600 is 3364. All divided by 42. I'm beginning to run out of room, so I'm going to document that in step 1 we discovered that x cannot be 0. Alright, so what is the square root of 3,364? It's a good thing I've got this calculator. That is 58. So x is equal to 40 plus or minus 58 divided by 42. And at this point I can split this into two values. X equals 40 plus 58 divided by 42, or x equals 40 minus 58 over 42. 40 plus 58 is 98. I'll reduce this fraction in a moment. 40 minus 58 is negative 18. And now I need to find the greatest common factor so that I can reduce both of these fractions. 98 and 42. Well, I know that 7 goes into both of those values. So let's divide both of them by 7. 98 divided by 7 is 14. 42 divided by 7 is 6. There's still an even number in here. I can take out the 2. And so that's going to give me x is equal to 7 over 3. Or, all right, over here, 6 goes into both of these. So that's going to give me negative 3 over 7, which cannot be reduced any further. So I get negative 3 over 7. Now remember, this was all in an effort to determine what x might be. We still have to check both of these values to see if they are truly the correct answers. The first thing we should compare to is the value we found in step 1 for what x cannot be. In step 1, we found that x cannot be 0. So these two numbers are probably both great, but we do have to check both of them. Let's check them one at a time. First, we're going to check x equals 7/3. Checking is very easy. You just have to plug back into your original equation. Everywhere you saw an x in your original equation, you're going to replace it with 7/3. So, the 21 will be multiplied by 7/3, and this 21 will be divided by 7/3. Now we just have to see if the left side and the right side are equal. Okay, 21 is in the top, 3 is in the bottom. And 21 divided by 3 is 7, which then gets multiplied by this 7 to make 49. Let's show the steps. (21) divided by 3 is 7, so we can replace 21 over 3 with 7 over 1. Each one of these 7 over 1s is just a 7, and 7 times 7 is 49. So on the left side, we get 9. On the right side, we have to remember the rule for dividing fractions, which is to keep, change, flip. So we keep the numerator, change the division into multiplication, flip the denominator. And we'll use a very similar approach to what we did a moment ago. We'll write 21 as 21 over 1. We'll note that 21 divided by 7 is 3, so we can replace 21 over 7 with 3 over 1. Now both of these is a 3 over 1, 3 over 1, which is just 3 times 3, which is 9, so this checks. So that tells me that this answer, 7/3, is correct. Now I just have to check the other one. We'll use the same method. 21 x minus 40 equals 21 over x. Everywhere there used to be an x, we're going to put negative 3/7. Okay, 21 is the same as 21 over 1. 21 divided by 7 is 3, so I can replace this with 3 over 1. Anything divided by 1 is itself, so this is just a 3, and this is just a negative 3. 3 times negative 3 is negative 9. Negative 9 minus 40 is negative 49. So on the left side, we have negative 49. On the right, we're going to keep change flip, so this will be 21 times 7 over negative 3. I'm going to write 21 as 21 over 1. Now, 21 divided by negative 3 is negative 7. So I will cancel both of those and write my negative 7. And negative 7 times positive 7 is negative 49. So the left side and the right side match, and that verifies that this answer is also correct. And with that, we have completed this problem.